Today I'm going to talk about LeetCode question number 417, Pacific Atlantic water flow. So there's an n by n rectangular island that borders both the Pacific and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You're given an n by n integer matrix, heights, where heights at this row and column represents the height above sea level of the cell at coordinate RC. Okay, so for example, here this is 5 unit points above sea level. The island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west, so not diagonally, if the neighboring cell's height is less than or equal to the current cell's height. Water can flow from any cell adjacent to an ocean into an ocean. Okay, so return a 2D list of grid coordinates result, where result RC denotes the rainwater can flow from cell RC to both the Pacific and Atlantic Oceans. Okay, so what this basically means is, so we need to find a cell where if it's high enough, if it's high enough sea level, it can drain into both the Pacific and Atlantic Ocean. So for example, 5 here, this is answer. This is one of the answers because it can flow both to the Atlantic Ocean through here or here, it doesn't matter where, we just need at least one path where it can flow. And it can flow to the Pacific Ocean either here or here. Okay, so that's why 5 is a potential solution. And this 5 is also a potential solution because it's already touching Atlantic and Pacific Ocean. We don't even need to check the path, so it's already touching both. Okay, same with this 5 at this corner, and this 6 flows not only to the Pacific Ocean here, but down here to the Atlantic Ocean, and etc. So that's how we're gonna figure it out. So that was the main idea. So what we can do is go cell by cell, and recursively call a depth first search function. Depth first search can help us easily traverse cells up, down, left, right of our current cell, and check if the adjacent cell is less than or equal to it. If it is, that's a path. That's one part of the path, and then for that cell we check the same thing in the next iteration in our next recursive call. If it can flow anywhere. For example, we have 4. It can obviously flow here, here, and here. In the next recursive call, let's say we look here, it cannot flow here. Okay, but it can flow here, etc. So like this is a possible path. Okay, and we do that for each cell, check in if it's able to reach the Pacific Ocean edges or the Atlantic Ocean edges, and if it does, then that's a solution. Okay, but this is kind of intensive because we are doing this for pretty much every cell in this matrix, and we're calling DFS on every single cell. There is an easier way to do this. So the main idea is, in the easier way, is if we have a cell and it can flow as long as the neighboring cell's height is less than or equal to it, then that means in this path, if you look at 2 here, the path goes 5 to less than or equal, or 2 greater than or equal. Okay, this path is the same. So instead of checking maybe a cell can go to an edge if the neighboring cell is less than or equal, how about we look at these edge cells and check if there's a path where we can go greater than or equal to that cell. Okay, for example, here this is a potential path. Okay, this is not and that's a potential path there. Okay, and that basically means 5 can flow here, and there's a potential path here, which means 5 can flow here. Okay, so why not just check those edges, just the edges, not every cell, just the edges. Okay, so for example, this guy can flow here, because instead of at the edges we're checking if it's greater than or equal, and this guy can flow here. Okay, and these paths indicate 5 can drain here and here. Okay, and so where am I going with this? Well, if we record the path where starting from the Pacific edges and the Atlantic edges, as far as they can go, so for like this cell here, so look at this cell, and it's along the Pacific edge, its coordinates would be, instead of writing coordinates, I'll just write the values themselves, 2, 3, 5, and then this 3, and then this 2 also counts, but I'm just going to simplify and say this path. And if we're looking at this node here, it can flow here, this Atlantic edge. So it would be 1, 3, 5, okay, and 5 is the biggest. We can't really go anywhere else. Okay, and you can kind of see 5 is a common factor in both of them. Oh, these positions are different. This is like 0, 1, 1, 2, and this is 0, 1, 2. These things are not equivalent, but we see these 5s are equivalent. Okay, so that is indicative of 5 can flow to the Pacific Ocean edge and can flow to the Atlantic Ocean edge. Okay, so that's going to be the main idea here. Instead of checking all the cells and whether it can flow downwards, we just check the edge cells and see if there's a path to a cell where of a higher altitude. Okay, and then we take those common cells between the two lists. This is the Pacific Ocean edge list, this is the Atlantic Ocean edge list, and whatever cells are in common, that means that cells can flow to the Pacific Ocean and the Atlantic Ocean. Okay, now to code it up, so what I'm going to do is denote my Pacific set and Atlantic set. So these sets are going to store the coordinates starting from the Pacific edge and Atlantic edge to as far we can travel to, where the neighboring cells are greater than or equal to the edge cell. Okay, and our final result is going to be an array of arrays. Okay, and what else? I want to, just to make it easier, store the row length and the column length. Okay, so now what we're going to do is first let's iterate the top and the bottom edges. So top and bottom, and when we do that, the the columns are changing values, but the row is always going to be at position 0. And down here, the columns are changing values, but the row is going to be always at position row len -1. So for I in range column length, I'm going to call helper on. So I'll fully flesh out helper a bit later, but I'll just define the function arguments right now. So row, column, ocean set, and visited. Okay, I'll define that a little bit later, but first I'm going to do this logic here. So I'm going to pass in the row, which is going to be 0. This is going to be our top, and then I, and then since we're at position row 0 and the varying column lengths, it's going to be for the Pacific Ocean. So I'm going to pass in this Pacific set and my visited dictionary here. Okay, and visited, it just helps us to keep track so we don't visit a node again. So if we're at 2, here and then we go to 2 here because it's greater than or equal to this previous 2, we don't want to go back. Okay, and also we're going to pass in none. And this none is going to represent the previous value that we're comparing our current cell against, okay? So if we were at this cell, we're going to obviously compare against this previous 2. If we were at this cell, we're always going to compare against this 2. If we were at this cell, we're obviously going to compare against this 4. Okay, and so on. And in here, it's going to be column -1 and I and Atlantic and a new dictionary set for this new call of the helper and none. Okay. Now I'm going to define left and right. So for left and right, what's going to change is, so column is going to stay 0 for column length -1, and the rows are going to be changing. So row length, okay, I and 0, and then this is going to be I, and then column length -1. Okay. That looks good. And then once we have our Pacific and Atlantic sets filled up, so we're going to iterate through one of them for I in the Pacific. If I in Atlantic, what we're going to do is store it in our final result array. Because if a node is in both, or so a position is in both I in Pacific and Atlantic, that means starting from the edge, we can flow to that node. Okay? Starting from the Pacific edge, we can flow to a node, and starting from the Atlantic edge, we can flow to that node. Okay? Done. And in these sets, we're going to store tuples. Row and column, and that's because in the tuple, and that's because in sets we can't store arrays. Yeah, this is the quirk, so we have to store it as tuples. So we're gonna have to convert it to an array here. So I 0 and I 1. and then finally return final result. Okay, so now let's flesh out this function here. So obviously we want to, this is going to be a DFS, depth first search, okay, where we get a node and explore all other adjacent nodes, and for those adjacent nodes, explore those adjacent nodes, etc. So for first, we want to check if row and column are in range of the grid, because we don't want an out of bounds error. So if row less than 0 or column less than 0, return, stop execution there. If row greater than or equal to row length or column greater than or equal to column length, then return. And also we want to check if the node we're at is of a valid path. If it's invalid, I mean, sorry. So we want to check if starting from a Pacific edge or Atlantic edge, if the nodes are greater than or equal. And if it's less than, so if you have 2 here and 1 here, obviously you can't flow there. So we stop execution there. So if proof is not none, and heights at row column is less than 3, and stop execution there. Otherwise, if we pass through these checks, then what we want to do is add that to our ocean set. Ocean set dot add row column, and then we also want to add this to our visited, because we don't want to visit a node specific index again. So visited I use a dictionary here, but we can easily use a set instead. Just use a dictionary just for convenience, so I can pass an empty dictionary every time. Okay, and otherwise what we're going to do is call help, recursively call helpful function on all 4 directions. Helper row column function set visited, and the previous value is going to be the value we have now. I'm going to call this 4 times in 4 different directions. So to the left and right and up, or sorry, this would be row would be up, down, and the column left and right. Okay. And yeah, that's pretty much it. This will populate our specific ocean set, whether it's Pacific or Atlantic, with all the valid paths starting at the edge here. And yeah, so I'll try compiling it. Maximum depth recursion. Oh, I forgot to check if row column in visited, then stop execution there. Okay, we don't want to visit it again. Okay, looks good. I'll try submitting. Okay, great. Thanks for watching. And this is O of M by N time, where Those are the lengths, row and column length of the heights matrix.